Hello, my name is Justin Ferralis, and today I will be doing problem 7.41. So it says that the 1 kilogram physics book is connected by a string to a 500-gram coffee cup. The book is given a push up the slope and released with a speed of 3 meters per second. The coefficients of friction are coefficient for the static is 0.5 and the coefficient for kinetic is 0.2. And how far does the book slide? So I already drew up the pictures or the free body diagrams. So for the book, as you can see in the drawing gave by the book, there's normal force acting up on it, and then there's kinetic friction going this way, and then there's also tension from the rope, and then there's gravity going straight down. And as you can see in my free body diagram, I have it's tilted a little bit because it's tilted here. Like if you were to draw a line, it would be like this. So yeah, so that's why it's tilted. And for the cup, there's only two things acting on it. There's the force of gravity pushing it down here, and then there's a tension going up. So the question says, how far does the book slide? So then I use the kinematic equation just to solve for delta x. So then the kinematic equation I used was Vf squared or equals V initial squared minus 2a delta x. So yeah, so then I just subtracted Vi squared, and then I divided by negative 2a. Yeah. And that should equal my delta x later on. So what I did was I took the book and I took the cup, and then I took the different so I took the y components from the book. Here. So this is the book. So the y components for the book is ma which equals 0. So it's the normal force minus mg, and that should equal 0. So n minus the 9.8 cosine 20, because this is the it would be right here, so adjacent, so then it would be the y. 9.8 cosine 20 equals 0. So this is just to solve for n, so I can find the kinetic friction. So I would have 9 minus 9.209 equals 0, so n would equal 9.209. And then the kinetic friction equals the coefficient times n. And the coefficient for the kinetic friction was 0.2 times 9.209. So the kinetic friction equaled 1.842. Now for the cup, the sum of the y's were that's tension, because it's going up, tension minus mg. So I'm taking all the stuff I'm taking it positive in the direction where it's positive, and negative where the direction is negative. So yeah, so in the book part, the n is going up, which is why I put it first, and then I put the mg negative. Yeah, so I got t minus mg equals ma. And then here I'm solving for t, so then when I do the sum of the x's, because the sum of the x's I need t and friction, fk, which is why I found it here. So yeah, so I'm here solving for t. So then t minus, and then my mass of the cup was 0.5 kgs times gravity, which is 9.8 meters per second squared, equals the 0.5 kgs times a. So then if I add this across, so 0.5 times 9.8 is 4.9. So I'm adding 4.9 across. So my tension would be 0.5 A plus 4.9. Yeah. Okay. Now I'm gonna do the sum of the x's for the book. So because it's asking how far the book slides. So sum of the x's for the book, and it equals negative t, because t is going to the left, minus the force of friction for kinetic, because it's going to the left, minus mg sine 20. And I'm using sine 20 here because that's the x component for gravity, because here's the angle, so then sine opposite. So yeah, so that's my x, and that equals ma. So I have minus t. T is 0.5 plus 4.9, or 0.5a plus 4.9. And then this is minus 1.842, and minus, oh wait, oh no, this is minus 1.842, and then the mg sine 20 equals minus 3.35. That equals 1a. So then I'll get minus 4.9 minus 0.5a minus 1.842 minus 3.335, and equals 1a. So I have like terms with the a's, so I add the a's. Then I'll get 1.5a equals this whole thing. These three terms are here. This one, this one, and this one. These will equal up to negative 10.092. And then here I'll just divide by 1.5. And I'll get my a, which is 6.728 meters per second squared. Now with that a, I can go back to the kinematic equation that I wrote up here. And now I can just plug in. So my Vf squared, so let me just rewrite this, Vf squared minus Vi squared over negative 2a plus delta x. So my Vf squared is going to be 0 because the book's going to be at rest. And then it said that originally it had to push up the slope with a 3 meters per second, so squared minus 2, and then my acceleration is right here. That equals delta x, and I already computed it, and my x final, because this is basically x finals minus x initial, and my x initial is going to be 0, so that just goes away. So my x final is going to end up being 0.67 meters, or 67 centimeters. Now, for the second part where it says, at the highest point does the book stick to the slope, or does it slide down? You have to use your n again that you found up here, but instead of using it for the kinetic friction, you have to use it for the static friction. So my n was 9.209, and then Fs max equals the static friction times n, and that it's going to equal 0.5 times 9.209, which is 4.605. So now I can do sum of the x's, which equals static friction minus tension minus mg sine 20. Yeah, which was like the same thing here, but instead of using kinetic friction, I used static friction. And this should equal 0. And then, yeah. And then I'm gonna solve for Fs, then I'm just get this by itself. So minus t minus mg sine 20 equals the static friction. And then t, as I put above, was okay. So I'm gonna multiply by a negative 1 just so I can get rid of the negatives everywhere. So it's t plus mg sine 20. And that should equal the static friction, or the Fs max. So t is 4.9 plus 0.5a, and then plus mg sine 20, which is 3.35. And then the acceleration here goes to 0 because the acceleration found up here was for the y component, but this is for the x component, and For the x component, the acceleration is 0. So yeah, so I get static friction equals 8.25, and the book will slide down because Fs max is greater than Fs, so it will slide down. And that's it. Thank you.